Alright, so we are continuing our discussions on building advanced RAG systems in this LangChain crash course series. So in this video I wanted to talk about the parent document retriever. So in some of the cases when we try to build a RAG system, your embeddings can be like either very specific or they are very small, which lacks the context, right? So a set of documents, then we kind of load that document using a few of the loaders which are available in LangChain. Then we kind of create the text chunks of those document, so that we split the document into smaller chunks, and then we create the embeddings, right? So in some of the cases this embeddings can be very small, or in some of the cases this embedding can be very large also, right, based on the size of these chunks. So now let's discuss what this parent document retriever is and what are the problems we are trying to solve using this parent document retriever, right? So as I mentioned, like if your embeddings are very big, then it can be non-specific, right? It's a very large embedding which does not have a specific meaning which is attached to that particular set of text chunk or the embedding, right? And in some of the cases your embeddings are very small, right? So which can be very specific and which can miss out the correct context of that parent document, right? So the two scenarios which we are trying to explain, right? So when your embeddings are very big, then it can be non-specific, and when your embeddings are very small, it can miss out the context related to the actual document, right? So the parent document retriever kind of strikes a balance between these two by splitting and storing the small chunks of the data, right? And this parent document refers to the document that a small document is originated from, right? So we kind of use the original document, then we call as parent document, and then we create a child documents and we create the subsequent embeddings out of those, right? So let's visualize the process, which will also help you to understand what I am trying to explain. Now we have the original document, right? Now we will split this original document to three parts. So we split our original documents and we are calling this as parent documents, right? So we have like parent 01, 02 and 03. Then what we do is we again split this parent documents to child documents. So now instead of having 3 embeddings, we will have 9 embeddings for a single document, right? So once we have this 9 child documents, then we will go ahead and create the 9 corresponding embeddings out of this child documents. And now when a user comes with a question, so that question will be first converted to embeddings, and then we will do a lookup, right? So which embeddings from this child document will be the closest match to the question, right? So we will say, for an example, like we have seen that the embedding 09 is kind of the correct match. Now what we can do is we can be happy and go ahead and retrieve the child 009 embedding, and which can give you the answer related to the question. But in case if you want to get more context, right, so more context to your question, then what we can do is, using this child embedding, we can also retrieve the parent embedding, right? So which will give you more context to the questions which we are trying to solve, right? So what the general steps are like: we use the original document, then we create a parent document splitter and we create the parent chunks, then we again do a child splitting, and then we create the child embeddings. And when a user comes with a question, we can just do a similarity matching and we can get the child document. And if we are not happy with the child document and we think that the child document does not have the correct context, then we can go back to the parent document and retrieve that, right? Now let's go ahead and try to implement this in LangChain, right? Alright, so this is the code implementation which we will go through now. So once this installations are done, so I am loading these 2 documents which are coming from a Kaggle dataset. So these are nothing but text document classification dataset. So I have picked up 2 text out of this, which are category of business class and one of the text is related to a Lufthansa airline, and the another is related to economics, the financial condition of Japan, right? Then using this text loader, I am just adding this documents to a list which is nothing but docs, and I'm using this text loader. So first of all, I'm creating a list, then I'm looping through that list and creating a document loader out of it. So after that, I will use the BG embedding. So if you haven't gone through my last video, so in the last video I talked about BG embedding in very much detail. I have also mentioned the link of that tutorial, which is kind of a state-of-the-art embedding which you can use to build a fully working rack system, right? And this is also open source embedding. Now, so you can do two things. Like if you want to use a parent document retriever, you can use in two ways. One of the way is like you can retrieve the full document, which will give you a larger context, right? So if you just see here, I am using a recursive character text splitter with a chunk size of 200, and then I'm creating a vector store, and then I'm using this parent document retriever where I am kind of mentioning my vector store, and also I'm mentioning the child splitter. So child splitter I have created here, where using this recursive text splitter, I'm mentioning that you split the document to a smaller chunks with a chunk size of 200, and you create smaller chunks of the data, right? So so if I just visualize this, so this is my original document. Now using this 200 chunk size, I have created several child documents, right? Now with that, let's try to understand what we can do with this. Now we will add the documents to the retriever, and once the documents are added, we can, if I just check the associated keys which are present in the store, there are only two keys which are present, because we have only added two documents to the store, right? Now what we can do is, now let's call the vectors search functionality, right? So we will use the vector store, and we will try to do a semantic search on top of that. So I'm asking a question: tell me what happened in the year 2014 in Japan, right? Then using the vector store, I am getting a page content which looks like this. Now this is a very small document because it has retrieved the child document, right? Or using the child embedding, and so this is the length of this is 197. Now what we can do is, using the retriever, right? So once using the retriever, we can also retrieve the full document, right? So let's now retrieve from the overall retriever, right, which should return the larger documents, since it returns the documents where the smaller chunks are located, right? So using that, you can see if I use the retriever, it will retrieve the parent document, and it will kind of give you the full document, right? So it will give you the full document because I am asking the question related to Japan, so it will retrieve the document which has the detail of the Japan, and it will give you the full document, right? So this full document will also be kind of give you more context, but it can also be non-specific, right? So the requirement which we are the question which we have, and if you are asking a question about that, then it will give you non-specific answer, because it is kind of retrieving the full document, right? So to tackle that, what we can do is we can split the parent document, right? So now if I try to visualize this, I have my original document. This is my original document. Then I create parent documents out of it, which has a larger chunk. So this is my original document, so I will write it org, and these are my parent documents, right, which is like p1, p2, p3, and using this parent documents, we will create subsplits, right, which are my child documents, right, which I also showed in the visualization process. So this is like c1, c2, and c3, until this it will go on like cn. So this parent document size is larger. You can see the chunk size I have mentioned here is 800. So this chunk size for this parent documents will be of 800 of size, right? 800 characters will be present in this all these parent documents, right? But if you see the child splitter, so this was my parent splitter, and this is my child splitter. Here I mentioned the chunk size equals to 200. So these are my smaller chunks where the chunk size is equals to 200, right? So now we can also retrieve a larger chunk, but if I like retrieve this P3 document, which will give you a larger context, but it will not retrieve the full document. So my full document is this, right? So in the previous code example which I showed, it was retrieving the full document, which can be a very large and which can be very non-specific. But if we use a smaller chunk and retrieve this, which can give you a larger context, but which can also give you the very specific instruction or the specific context to your question, right? Now let's go and see how the code works. So here you can see in the parent document retriever, I am mentioning my child splitter and also the parent splitter, right? So it will kind of create the retriever in such a way that the relationship between the child documents and the parent documents are kind of maintained, and it will store those relationship in this parent retriever, right? So after that I will add the documents in this parent retriever. Then now if you can see, like now if I check the number of keys that are present in this retriever or the store, there are 6 keys which are present, because we have used the concept of parent splitter and the child splitter, right? Now if I just do a vector store search, like tell me what happened in the year 2014 in Japan, now you will see using the vector store we will get the similar sort of embedding result. The length is very similar to the previous approach we used, right, which is 197. But now if we use the parent document retriever, so it will retrieve the larger context, but it will not retrieve the full document, right, which happened in the previous case. Now the length is 795, and if you just check the page content, it is much more specific to the question, and it has a smaller length compared to the previous approach where we retrieve the full document, right? Now what we can do is, why we should bother about using this parent retriever, right? So if you are building a retriever QA and you want to retrieve answer which has a correct context, then you can use a large language model, and in that using that large language model you kind of specify the retriever as this parent retriever, right? Instead of vector store, you can mention the retriever equals to parent retriever in this retrieval QA generation, and it will give you kind of better results in terms of retrieving the context, right? So yeah, so I hope you got an understanding what is the benefit of using a parent document retriever, which can give you specific and smaller context according to the questions, instead of retrieving the full document, or instead of retrieving a very specific answer which may lack the context of the question, right? So with this I will end this video. Please give a like if you found this video useful, and also subscribe this channel if you haven't. Thank you. See you in the next video of this LangChain crash course series.